Hey guys, what's up? This is going to be the next lecture from mine, and what today is, it's about the physical properties of amines, and I'll talk about the physical state, talk about the color, and then it's going to be their order, and the last two will be solubility and boiling point. So I need to take one by one each of them. So like I said, the first thing I'm talking is the physical state here, right? So just concentrate and get to know what this is about. So this is about physical state. What you need to consider here, that amines up to 3 carbon are gases, right? And amines from 4 to 8 carbon, they are liquid, and 9 onwards, amine from 9 onwards, they are solid. So let me explain a bit about, initial 3 members are gaseous, and next 5 members are actually liquid, and all other higher members starting from 9 to any number you can compare, they are all solid. Why it happens? It's because as the number of carbon increases in amine, not only the mass increases, but it also increases the van der Waals force of attraction between the molecules. So higher the mass, higher will be van der Waals force of attraction, and that's the reason first they are gases, but as the number of carbon increases, they become liquid, and finally they become solid. Let's talk about the second important feature. So the second one is about their order. Now about order, I would say they have fishy smell. So for me, this doesn't smell good because it has a fish-like smell. And third is going to be about and color. Usually colorless. They are usually colorless, but on oxidation, they become colorless. They become colored. What fourth important thing is there, it's about the solubility. So the solubility, let's take the example here. Suppose I am talking about 1 degree amine here. So this is your 1 degree amine, and then I'm taking your 2 degree amine, and finally there will be 3 degree amine. So this is your 1 degree amine, this is your 2 degree amine, that's your 3 degree amine. Now, what very important thing is there, the solubility depends on number of hydrogen bond a molecule can form with the water. So as you can see, there are two hydrogen here, so they can form 2 hydrogen bond. Right, with water, with H2O. But like you can see, this can form only 1 hydrogen bond. With water. But there, as you can see, there is no hydrogen left here, so no hydrogen bond will be formed. No H bond is formed. So now you have probably understand by your own that more the number of hydrogen bond with the water, greater will be solubility. Hence, the solubility of primary amine is highest as compared to the secondary, and this one has the lowest solubility here. So this is the trend of the solubility. Another very important thing is that this is going to be something really important. So let me make a box here. Amines of one type solubility depends on number of carbon in the alkyl group as well. What that mean? Let me explain you. Suppose I am talking about methanamine, I am talking about ethanamine, propanamine, butanamine. So all these are actually primary amine, right? But as the number of carbon increases, the solubility decreases. Why? Because with increase in number of carbon, the hydrophobic nature of the amine also increases here. So for very simple reason, I am just taking you through another aspect here, that suppose I am talking about CH3NH2, and then I am talking about C2H5NH2, then the solubility of methanamine would be higher, right? Solubility of methanamine would be higher, and if there is C3H7, there is C3H7NH2, the solubility is going to be higher for ethanamine, and then it's going to be for propanamine. So this is also very important. Let me repeat back. Even though two or more amines belonging to 1 degree amine or 2 degree amine or 3 degree amine, the solubility depends on number of carbon they have. More the number of carbon, less will be the solubility, because with increasing number of carbon, the hydrophobic nature also increases. Now we are up to the fifth factor, that is the boiling point. Boiling point actually depends on number of hydrogen bonds in the amines, molecule. What that mean? More the number of hydrogen bond an amine can form, greater will be the boiling point here. So how this looks like? This looks like, suppose I'm talking about RNH2, then what will happen? This can form two hydrogen bond, but if you consider two, if this is your secondary amine, then as you can see, there are two hydrogen bond here. Two hydrogen bond can be formed, but there only one hydrogen bond can be formed. And in tertiary, no hydrogen bond can be formed. So the boiling point of this one is going to be highest, and then it's going to be this one, and then the tertiary one. Let's compare, alcohol, and then, amine, right? And then, let's take exact number of carbon. So I'm talking about C2H5OH, and there is also C2H5NH2, and talk about C2H5, right, and C2H6. So this is your alcohol, ethanol. This is your ethanamine, and then you have ethane. So if there is a question like out of these three which one has a higher boiling point, then the answer is that ethanol is having higher boiling point as compared to amine, and amine is having higher boiling point as compared to ethane. Why? You do know that oxygen has more electronegativity. So because of highest electronegativity, as compared to nitrogen and oxygen hydrogen bond strength will be much more stronger, and therefore the bond enthalpy is going to be higher, and hence ethanol will be having the highest boiling point, and ethanamine would be a slightly less, and finally ethane would be the absolutely least one. So these are some of the factors actually I wanted to decide, I wanted to make you go in the physical property.